This presentation is about using Venn diagrams to solve problems. It's an example using a Venn diagram to solve a problem about people's preferences on ice cream flavors. So the story goes, in a recent survey, people were asked if they liked several flavors of ice cream. A person might answer yes to one or more flavors. You could like two of the flavors. You might not like any of the flavors. And the survey only asked about opinions about chocolate, vanilla, and strawberry ice cream. And so you get these results that are presented here in sort of a complicated way, and we need to sort out what it really means. The Venn diagram will help with that. So the results were that 32 like chocolate, 31 like vanilla, 29 like strawberry, and 2 do not like any flavor of ice cream at all. But then it gets more complicated. 10 like all 3 flavors, 8 like chocolate and vanilla but not strawberry, 6 like vanilla only, 9 like strawberry and chocolate but not vanilla. Okay. And we'll get rid of that last sentence there. So we want to draw the Venn diagram for the situation and find out the number of people in each component of the diagram. And that's a vocabulary word. I have to illustrate in the picture what a component is. So I'm going to turn off the video here for a moment. I'm going to go over and write on the piece of graph paper to draw the diagram for this situation. So first of all, I'm going to draw a box. And this box represents the set of all the people who took the survey. So that's the universal set for the problem. I'll use a letter U to stand for it, but it doesn't really need a letter. Now, so what you imagine is that each little dot, each point inside this square is a person, a participant in the survey. And then we have the ones who like chocolate. C is the set of all participants who like chocolate. So each dot inside the circle is a person, a participant. Each little location is one person who likes chocolate. And then we'll have the people who like vanilla. And then we'll have the ones like strawberry. Now, each component of the diagram is one of these regions where all the points within the region, you could walk from one to the other by some path without crossing one of the border lines. So, this is a component here, and this over here is a different component. It's like this region out here is all one component because you could walk from any point in here over to any other point without crossing a border. What the problem is asking us to do is to fill in the numbers in each component of the diagram. And the key is to look at the given information and pick out the pieces of the given information that are the simplest. Like when you say 32 like chocolate, that is not a simple piece of information because what you're saying there is that all four of the components that make up the chocolate subset, when added together, total 32. This plus this plus this plus that all add up to 32. And that's not a whole lot of information because we don't know how to put any particular numbers in any of the four square components. In the same way with the 31 and the 29 here, those are all facts about some big region comprising multiple components. But when you come to 2 do not like any flavor, now there's a simple fact that we can use real easy because that's saying there's 2 people in the box who took the survey who are outside all 3 of the circles, not in any of the circles. So I can put a 2 out here right away. Okay. So this fact we've used that fact now, and it was an easy one. And let's look here. 10 people like all 3 flavors. Where in the diagram are the people who like all 3? That's got to be a person he's inside the blue, but he's also inside the pink. So he's inside the overlap between the blue and the pink. But he likes all 3 flavors, so he's also in the red. He's in all 3 of them. He's in the triple overlap. Person who said yes to all 3 flavors. That would be me. Okay, so there's 10 people in there. Okay, so we've used up those 2 facts. Now, 8 like chocolate and vanilla, but not strawberry. Okay, so we're in the overlap of the blue and the red and the pink. We like chocolate, we like vanilla, so we're inside this little football shape, but not strawberry. We're not one of those 10 people who like all 3. So we have 8 people out here who are in V intersect C, but not in S. I'm going to write some things in symbols on the paper just to practice with the notation. I'm writing down what we've already used, so I'm not going to really use the symbols to solve the problem. I'm just going to write the symbols to remind you what they mean. Like these 2 people out here. Those guys are in the complement of C, not inside C. They're also in the complement of V, the points in U that don't belong to V. And they're in the complement of S, all 3. They're in the intersection of all 3 complements, the outsides, the intersection of all the outsides. The number of individuals, that's a set of individuals, and the cardinality of that set, the number of individuals in there, is 2. And how about this 10? That's the intersection, what the chocolate likers and the vanilla likers and the strawberry likers all have in common. The set of people who belong to all 3, the overlap of all 3. That set of people has a cardinality of 10 members. And then this 8 here, that's the overlap, the intersection between the chocolate and vanilla fans, intersected what they have in common with the complement of the strawberry fans. So that's 8. So that's how you can use the notation to write the given information in symbols. No, we didn't really need it in order to just fill in the diagram. Okay. So let's see what information remains to be used. 6 like vanilla only. Where's vanilla only? It's inside the pink vanilla circle, but outside the other 2 circles. There's 6. Nine like chocolate and strawberry. They're in the blue and the red circles both, but not vanilla, not in the pink circle. 9 like chocolate and strawberry, but not vanilla. Okay. So now maybe we can go back to this harder information. Now maybe some of it can be more useful. Like 32 of them like chocolate. So these 4 numbers here add up to 32. So 8 plus 9 plus 10 plus, I don't know, let's call this X, equals 32. So what's that? 27 plus x is 32. And 32 minus 27 is 5. So we got 5 people over there. I've used up my information about the chocolate group as a whole. 31 like vanilla. Okay. So this, and this. Those 4 add up to 31. So 10 plus 8 plus 6 plus y equals 31. So 24 plus y is 31. Y equals 7. The only remaining fact we can use is the 29 like strawberry. All these guys add up to 29. So 9 plus 10 plus 7. Plus z equals, this is z here. That all adds up to 29. So 26 plus z is 29, so z is 3. And now we've filled in all the components of the Venn diagram, which was the question. Now in your homework, that's kind of the first step. They'll ask you things, other questions. You know, they'll go on and ask something like, okay, so now how many like strawberry but not chocolate, you know? And then you'd say, oh, that's the 7 plus the 3. But whatever they ask, you just ignore the questions that they ask and just fill out the whole diagram in whatever order is easiest to figure out. And then once you've filled in the whole diagram, then whatever questions they come up with, you can figure the answer from there. And when I say fill out the diagram in whatever order is easy, you say, how do I know what order is easy? Well, like the triple overlaps are the easiest, and then the double overlaps, you know, are the next, and then just a fact about just a single thing, a single subset is the hardest to use, so you use the other ones first. And complements also, like if you have the intersection of 2 complements, that's just as good as the intersection of 2 of the sets. So if you have a triple overlap of sets or a triple overlap of complements, that's easy. And the double overlaps are the next easiest. And where it's giving you information that's not about any overlap at all, that's the hardest to use. And so you use the easiest information first, work your way back, and you can fill in the diagram. The homework question is, it's only 3 sets, like our chocolate, vanilla, strawberry. It's not 4. You could do 4, but it's a little harder to draw that 4th set in there. It has to be kind of a snake that wraps around so that, you know, you get a component for every possible kind of overlap. And then if you went beyond that to like 5, you might not even be able to draw it in the plane. You know, you might need to go to, instead of circles on a flat piece of paper, you could have balls and 3 space, you know. So, so this is as hard as it gets for the homework. Just gets across the concept of what's a Venn diagram and how do you use one. And it's a little bit of you know, deductive reasoning, problem solving. And you know, the key to success with these is you got to persist and you got to check yourself, and that's all it comes down to. So good luck with those, and that's all for this presentation.